Now in terms of this one, this one we're going to have to go through and factor out ourselves. Now general shape is again going to be just a straight cubic equation. For my zeros, now here's the thing. Everybody's going to be like, oh my goodness, I don't want to have to go through and factor this. But now remember, when you do synthetic division, your remainder, if it's not equal to 0, is the value of that number when you plug it in. And so if you do that, the nice thing is going to be that you can then use that point as something that you can graph and make a more accurate graph. Okay, now for possibles, you've got the factors of 6 over factors of 2. So 1, 2, 3, plus or minus 1, 2, 3, 6 over 1 and 2. So you've got plus and minus 1, 2, 3, 6. So that's 1, 2, 3, and 6 all over 1. Now I'm going to do all those over 2. So I get 1/2. 2 over 2 I have, 3 over 2 I don't have, and 6 over 2 I have. So we've got 6 times 2 is 12 possibles here. By Descartes' rule of sign, I've got 1 sign change here and 2 sign changes here. So positive is going to be the better way to check it out. Because as I said, these are going to have real zeros. I'm not going to throw the imaginary ones at you yet. So now it's just a matter of checking. 6 is probably going to be a little extreme to decide which way to run off. I'm also not going to probably pull fractions right now just for sake of ease. So let's try one. So if I do 1, I get, drop the 2, 2, negative 3, negative 3, negative 4, negative 4, 2. Now again, as I said, that's going to look, oh no, Mr. Hayes, I didn't get it. I didn't get a 0. But what we did get now is that we do know that the point 1, 2 is on my graph. So that's going to be one extra point that we can plot, or we don't have to figure out later. Okay? So let's try maybe 2. So I get 2, negative 5, negative 1, 6. And I'm fine if you erase your work. I'll do it again. So 2, 4, negative 1, negative 2, negative 3. Yay, we found one. Negative 6, 0. Okay, so one of our zeros is going to be, so far we got f of x is going to equal x minus 2. Now we got to factor this out because this is going to be 2x squared minus 1x minus 3. So this is going to factor out to be, we have to have 2x in one place, and x in another, then we have to have the 1 and the 3. So either 1 goes here, 3 goes here, 3 goes here, 1 goes here. This is going to be a minus 3 and a positive 1. So when you multiply that out, you're going to end up with zeros then of, well here, let me put these over here so it looks all nice and neat. So my zeros are now 2, this becomes 3/2, this becomes negative 1. In terms of finding your points to plot, we now have a point in between 1 and negative 1, so we know what that's going to be. So we've got 2 is going to go to a 0. 3/2 is going to go to a 0. Now this is so tight because they're only 1/2 apart. I'm not going to go through and actually plot a point there. We're just going to make a little bump to worry about. Negative 1 goes to 0. I'm sorry, let me move that so we got a little bit more space. Negative 1 goes to 0. Now we already know from what we did up there that 1 goes to 2. I would probably do a 0 here just to be safe, to make sure it looks nice. So then we get negative 2, if I plug it up here into the factored form, negative 2 times negative 3 times 1. So that's going to go all the way up to a 6. Likewise, let's pick out a different number down here. So let's say maybe 3. So then I'm going to get 1 times 1 times 4. Okay. Oh, I take that back. That's going to be 1 times 1. 1, that's going to become 3 and 4. So that's going to become 12. And then, last but not least, we'll do one on the end of negative 1. So we're going to go negative 2. So that's going to become negative 4. And then we get negative 4 minus 3, which would be negative 7. So this is going to be very large. This will be negative 28. All right. So in terms of plotting these, set up your axes. So everything looks all nice and neat. So I've got my zeros here at 2, 3/2, and -1. At 3, remember we're going up to 12, so we're going to be way up here. So this gets really big really fast. At 1, we're going to go up to 2. At 0, we were at 6, if I remember correctly. And then -28. Okay, so 0 goes up to 6, 2, 4, 6, and then this one we're way down here. Okay, so again, we've got the regular shape. Again, Mr. Hayes is going to have a hard time with this. So we can go all the way up. Wow, this is bad. Get that. Undo. Sorry. I was going to just try moving it for you. Hey, that works. All right, so you get your general shape like that. You do have arrows on the end, remember? And once again, graphing with a slate is not fun. And there you go. Now notice what's happening here. And this is going to, when we start getting to multiplicities, what's going to happen. As the two zeros get closer and closer together, okay, first of all, the dip isn't as large. And second of all, if the number ends up happening more than once, what's going to end up happening is that, notice on both sides of these have positives, so you end up getting a bounce. And we'll do one of those real quick. So I'm just going to do general here. Sorry, I've got to find my... Okay. So let's say we have... I'm going to make this general example. So I'm not going to go through and plot all the points of, let's say f of x is equal to x minus 2 times x plus 1 squared. Okay, so I have zeros at 2 and -1. General shape is going to be like this. Now the thing is that I've got a 0 here at -1. I've got a 0 here at 2. This one happens twice. And so when you come up and do this, now remember what was happening when the two zeros got closer and closer together, it came up positive. So you're going to bounce off of that, and then you're going to come back up and go that way. Okay? So it's going to act, somebody said once, oops, that didn't work. One of my students had said, well, it's almost like it's looking like a parabola right where that's happening. And I said, well, yeah, that's actually kind of the case. If you zoom in just on that spot there, you'll notice, look, it kind of looks parabolic. And the same thing is going to happen to you anytime you have an even answer. If you had something where, let's say, you ended up, oh, let's tack on x minus 5 to the third. Okay, this will have to be negative to make this work. So you come up, you come over, and then over here at x minus 5, you'd have, since it's happening 3 times, it's going to act kind of cubic. So you're going to come down into it, and you're going to twist, and then come back down. Okay, so again, you're getting that cubic shape where you're twisting as you're going through the root. Okay, so that is a very long-winded 3.4. I trust that you guys find that helpful. And if you have any questions, talk to me in class. Thanks.